This course pulls together several key concepts of using Jenkins for continuous integration. First, it focuses on automation, which is how we create repeatable project builds to support continuous integration practices. Specifically, we focus on automating quality assurance using a variety of tools that can be incorporated into our builds. By the end of this course, you'll understand how to automate the delivery of software that passes through a gauntlet of quality assessments. With these quality validations established in Jenkins, you can rest assured that your continuous integration, delivery, or deployment practices are delivering top notch software. Let's talk a little bit about how that is achieved. Automating quality assurance hinges on the interplay between Jenkins and a build tool. In our case, the build tool is Maven. Throughout this course, you will see that Maven is the unsung hero in the process. The automated quality assurance tools are often executed via a Maven plugin as part of the Maven build. These executions produce reports that detail the status of each particular focus area, which we'll discuss in a minute. Jenkins then leverages these reports to provide information in the continuous integration server and to control the status of a build. The information relayed in the reports can actually be used to stop the execution of a build if necessary. Now that we discussed the process, let's talk about the tools we'll be using to automate quality assurance checks. The first tool we'll be using is a pretty common tool. It's jUnit. Within Maven builds, there is built-in support for conducting unit testing with jUnit. With unit testing, we are assessing the correctness or the function of individual functions or particular lines of code within our application, just to ensure they work properly. We'll then take a look at JaCoCo, which is able to assess the coverage that our unit tests provide for our source code. We may see that 90% of our source code is covered by our unit testing. From there, we'll move on to take a look at FindBugs. FindBugs performs static code analysis that can detect quality defects within our software. So it's able to pick up simple bugs like null pointers. It can also pick up security issues that are present within the code base. From there, we'll take a look at Checkstyle to see how we can evaluate the structure and formatting within our code. And Checkstyle helps us produce uniform code that looks the same and is formatted the same for all developers on our team. Using these tools, we're going to build quality into our deployment practices and into our automated deployment pipeline. For each of these tools we discussed, we'll see how they can be integrated within Jenkins to influence the status or execution of our Jenkins project builds. Let's jump into some hands-on demonstrations. In this lesson, we'll make some adjustments to our Maven project to allow for JUnit testing and reporting within Jenkins. Within our deployment pipeline, it is important to understand that Maven is responsible for performing the testing. Jenkins simply displays the test reports for each of our builds. Keeping this in mind, let's start to modify the Maven test dependency project. To get started, I'm going to navigate to my desktop and I'm going to open the workspace directory where I have been keeping the code for my projects. Within the Maven test dependency project, you'll notice that we have the pom.xml file, and that describes our project and is used by Maven to build out our application. I'm going to open the pom.xml file using Notepad. We're then going to go ahead and make some changes to our pom.xml file. So the first thing we'll do is add a dependencies tag to the file. Go ahead and add the closing tag at the same time. Then within that, we add a singular dependency tag as well as its end tag. From here, we can then specify the coordinates of an artifact that we would like to include within our build. In this case, we're going to be using the jUnit artifact, and its group ID is jUnit. And then we have to specify the artifact ID, which is also jUnit. Then from there, we specify the version. In this case, I'm going to use version 4.12. We now have included the jUnit artifact within our Maven project. We can now create unit tests within the project and have them executed when we run our Maven build. The jUnit dependency provides the jUnit library that will execute our tests as the Maven lifecycle executes. We can close this file. Now let's navigate into the source directory. This is the standard directory structure provided by Maven, and we put our test cases within the source test Java directory. I'm going to also package out this directory. I'm going to use com O'Reilly. Within the O'Reilly folder, I'm going to create the Jenkins folder. Then inside of this folder, we can create our tests. So I'll just create a new text file. I'm going to name this file message source test, then give it a .java extension. It's okay to change the file's extension type. We can now open this file with Notepad and build out our unit test. So the first thing we need to do is place this class file within its package. Then we need to import the JUnit classes that we'll be using. We often just include the entire assert package. Now we need to include the JUnit test class. From here, we can go on to declare our actual class that we'll be placing the tests within. Inside of this class, we're going to create a method that's annotated with the test annotation. It's going to be a void return type for this method that we will simply call test. Then within the body of this method, we're going to simply fail the test and we'll say that it's not implemented. There we have our Java class, and this is our JUnit test that we're going to be executing as part of our build. Let's go ahead, close our class. Now we're going to navigate back to the workspace. Now we can go ahead and bash into this directory. Just right-click on the Maven test dependency directory and select Git Bash here. Within this directory, if we take a look at the status of our project, you can see that there are files that have not been committed to the Maven repository. So I'm just going to add those files. Now, if we take a look at the status of our project, you can see the modifications to the POM and the newly created message source test class are included in this Git repository. From there, we simply go ahead and we commit the changes, and we'll just say that we are adding tests, and now the files have been committed. And since the polling has been set up on that Git repository, we see that Jenkins automatically kicks off a build of our Maven test dependency. Luckily for us, there is integration for jUnit reports already in Jenkins for Maven builds. So if we take a look at the Maven test dependency, you see that we have a test result that actually failed. This tells us that we have appropriately configured our jUnit tests for our project, and we can use this base to further explore some of the jUnit integration within Jenkins. In this lesson, we're going to take a closer look at some of the support for jUnit within Jenkins. We have established our Maven test dependency project and the jUnit test within its Maven build. So we are simply able to go into that project, and if we build now, you'll see a build is kicked off. When we take a closer look at that build, once it finishes executing, we're going to be able to inspect the JUnit integration within Jenkins. There, the build has completed. One of the first things you'll notice is we get the test result trend. This is a graph showing the amount of tests that have passed or failed for our project. We see that we have had one test fail for build 30 and 31. You'll also see that we have the latest test result displayed for our project. Let's actually go ahead and dive into the build of our project. If we take a look at the console output, we can see the failing test. There we see the stack trace of the test that failed for com.o'reilly.jenkins.messageSource test. We can also see that during the build process, it was noted there are test failures. And if we take a final look at the bottom of the output for our build, you'll notice that we did not proceed because the build was unstable. This means that any dependencies that are downstream of our project were not built. For example, the Maven test project that we have established within Jenkins was not built because there were issues detected with the tests found in our Maven test dependency, build number 31. Now, if we take a look at the test results for the build, we get some more information. So here's a report that displays each module that was tested, as well as information about the failed tests. Now, in this case, we just have one test that was executed. We can drill down into that test to see its console output. So this is a subsection of what we saw within the entire output for the build itself. We can also take a look at the history of the tests being executed. Here we see build number 30, and we're able to take a look at how the tests have been resolved. We're still failing. Turning back to the test results, you'll also see that we can get further information and access the stack trace from the test result page. Let's actually fix this test so that it is successful and then take a look at what happens. I'm going to open our workspace where we store our Git repositories, and then I'm going to navigate into the Maven test dependency project. From here, I can open up our JUnit test, and we're going to set the test up so it will always pass. Let's just comment out the failing invocation, and now we can assert true that 1 is always equal to 1. So we should pass with flying colors. Now that we've made that change to cause our test to always pass, let's head back to the workspace directory, and we're going to bash into the Maven test dependency directory. We will add the changes to the Git stage. Then we're going to commit those changes to trigger a build. So there I have committed, and we should see in a minute here, if we navigate back to Jenkins, that a new build will enter the queue, and it's depending upon the polling interval here. There it is. We see we are conducting build number 32. You'll notice that Maven test is on build number 33, so let's see exactly what happens here. The upstream project Maven test dependency passed all of its tests, and that causes the build to cascade to the downstream project Maven test, which just incremented to build number 34. Let's dive back into the Maven test dependency project, and I'll disable auto refresh now since it's no longer needed. But you see that our test went to passing. You also see that we then built our downstream project. And if we dive further into the build, we can take a look at the test results. And we see that there were no failing tests within our test results. That's great to see that we had completed tests and that allowed our build to be successful. Then if we take a look at the project page, we see the success depicted within the graph and everything as well with our Maven projects that have that dependency between them. So we took a look at the integration for JUnit within Jenkins and explored how a failing unit test can impact the build of one of our projects. We see that builds become unstable when unit tests fail, and that can impact different activities or steps within our builds and prevent them from occurring. And it can also impact the cascading of builds to downstream projects. In this lesson, we're going to enhance our Maven build by adding some code coverage analysis provided by JaCoCo. JaCoCo is a code coverage analysis tool that inspects our unit tests and our code base and is able to report some metrics based upon the amount of code that is actually tested by our unit tests. Configuring code coverage analysis is very similar to the way we configured our unit tests with jUnit. We're actually going to build this capability into our Maven build, and then we're able to leverage the reports that are generated by that capability within Jenkins. To get started, we need to modify our Maven build. To do that, I'm going to navigate to my desktop and open the workspace directory, which contains our Git repositories. Within the Maven test dependency directory, we'll find our pom.xml file, which describes the Maven project. We can open this file with Notepad, and here we can begin to configure the JaCoCo Maven plugin. To do that, we start within the build tag of the pom.xml file, and we specify the plugins that we would like to execute for this project's build. And within that plugins tag, we have a singular plugin tag where we define the coordinates to our JaCoCo Maven plugin. So we're using Maven coordinates, and that consists of a group ID as well as an artifact ID and also a version. Let's go ahead and provide values for each of these coordinates. So the group ID is org.jacoco, and the artifact ID is jacoco-maven-plugin. For the version, pay close attention here. We're using the 0.7.5.2015 05241946 version. Not the way I would recommend versioning your files, but that is the version of the file that we need. From there, we can move on to specifying executions. Within the plugin tag, we're able to specify these executions. And they basically say when particular goals of the plugin should be executed during the Maven build lifecycle. We provide the singular execution tag within the executions tag. Let's copy this tag because we're going to actually have two executions. Within the execution tag, we need to provide some information, including an ID for the execution. In this case, we're going to call it the default prepare agent. We just wrap that in an ID tag. Then we specify the goal that we would like to execute. We create a goal tag wrapped inside of a goals tag. And the goal that we want to execute on the plugin is the prepare agent goal. At this point, we can just go ahead and copy these 4 lines because we're going to have something similar within our next execution. So we'll put those lines in place. So for the ID tag of the next execution, we want to specify it as default-report. We're going to be executing the report goal, which will generate the reports on the code coverage of our unit tests. We're going to add an additional tag in here, the phase tag. This simply says which phase of the Maven lifecycle we would like our goal to execute within. You'll notice that our first execution does not include a phase tag. That's because the plugins can have default phases included in their configuration. When we don't specify a phase, that is when they execute. We're also able to specify more explicitly when we would like a goal to execute during the Maven lifecycle. At this point, we have our configuration in place, and I would urge you to take a minute to check the syntax of the configuration to make sure you've closed all of your tags appropriately and to look for any spelling mistakes. If you're satisfied with your configuration, go ahead and save the file and then close it. Don't worry if we encounter any errors. We can always return to the file and correct them. Now that we've closed the file, let's navigate back to the workspace. We're going to open a bash console within our Maven test dependency directory. Before we commit anything, we're just going to use the Maven installation found on our path to execute the Maven clean and install goals. This is a way to test our configuration to make sure that we have appropriately configured the JaCoCo plugin. We see that we had build success, and that indicates to me that the configuration is in place appropriately. Our Maven build is now set up to perform code coverage analysis with JaCoCo. Now that we have JaCoCo code coverage analysis set up within our Maven build, we're going to go ahead and install the JaCoCo plugin for Jenkins. This plugin is going to allow us to display the JaCoCo code coverage reports within our Jenkins instance. It also provides us with some additional features that allow us to control the execution of our builds based upon the results of our code coverage analysis. To get started, let's navigate into the Manage Jenkins section, and then we're going to access the Plugin Manager. Within the Plugin Manager, I'm going to click on the Available tab to see a list of Jenkins plugins that I can install. From there, I'm going to filter the plugins, looking for the JaCoCo plugin. There I see it shows up once the filter's applied. I'll check the box next to the JaCoCo plugin, and then I'm going to hit Install Without Restart. Once I hit that, you'll see that we start the installation of the JaCoCo plugin and get some more information about the status of the install. There we can see that the plugin was successfully installed, and I'm going to actually return to our home page, go back into Manage Jenkins, into the Plugin Manager, and then check that it is indeed installed on our Jenkins instance. There we see the JaCoCo plugin, version 2.2. Now, if we take a look on the dashboard, we can navigate into our Maven test dependency project. Within the configuration section, we can validate that the plugin was installed even further by checking out the post build actions. You should see an option to record JaCoCo coverage report. If we check that, we see that we get additional configurations that we can apply as a post-build action. We'll talk a little bit more about these configurations as we proceed. In this lesson, we're going to configure our first Jenkins build that will leverage the JaCoCo plugin. We're going to navigate into the Maven test dependency project. We'll start to configure the project. At the bottom of the configuration form, we can select the Record JaCoCo Coverage Report within the post-build actions. The configuration that comes out of the box is perfect for what we have established within Maven. We can, at this point, actually apply this configuration we will have a working JaCoCo code coverage analysis, and the reports will display within Jenkins. Let's navigate to the workspace. Within the workspace, we're going to open a Bash console. You can see that we need to add the changes to our pom.xml file. Let's go ahead, add those changes, and then we will commit those changes. We'll say adding code coverage here. And at this point, when we commit, that should trigger a build within Jenkins. So if we return to Jenkins, we should see in a moment that the code coverage analysis and our Jenkins build will kick off. There we see the Maven test dependency build start, and it should move to the executor status here in a minute. And we see build 85 in progress. Let's actually drill down into that build. Once it completes, we see that we get information regarding the code coverage, and that's provided by JaCoCo. Here you see an overall code coverage summary. We're not doing too well. In fact, we can go into the detailed view and get some more information. Here we see that there are 3 lines. None of them are covered by our test. If we take a look back at our code, you'll see that the test that we established really doesn't do too much, and that's why there is no code coverage. Let's open that with Notepad, and you can see we're just asserting that 1 is equal to 1. Well, that's not very helpful. Let's take a look at the code that we would like to test, and that's within the source main Java com O'Reilly Jenkins directory. And if we open that up, you see that we have the message source class. Let's grab this string that we can receive from the message source class. We'll modify our unit test to check the getMessage method. We're going to create a new message source, and we're going to invoke the getMessage method on that object, and then we're going to check that the message is equal to the string that is contained within that class. Once again, this is kind of a nonsensical type of test, but it's going to provide us with some coverage metrics. Let's put that in place, save our JUnit test. Now I'm going to navigate back to our bash shell. We can once again add our changes to the git stage. We can then commit those changes. We should now trigger another build within Jenkins. So let's keep an eye. There we see it's already in the build queue. Should move to the executor status in a minute. There it goes. We're kicking off build number 86. We can navigate into that build, wait for the build to finish. There we see the build is finished. Now we are doing much better with our code coverage. We can see that we have 100% code coverage across the board. When we look at the report, you can see historically from one build to the next how much our code coverage has improved. There was the old line where basically we had 3 lines, I believe, that were not being tested. And now every line in the application is being tested. One of the things that you can do if you navigate to the project and its configuration is you can configure JaCoCo not to proceed with a build based upon some of those metrics it collects. So you can say if the line percentage or the code coverage in terms of percentage of lines is above 50, then we want to consider the build successful. We may want to say there's problems if it's below 40. So these 2 sections of the JaCoCo plugin within our post-build actions allow us to change the status of a build based upon some thresholds that we establish in order for our code coverage. You can also fail the build if the code coverage changes by a certain percent. We can say if there's a 10% drop in the amount of methods that are covered by our unit tests, then we want to go ahead and fail the build and that will prevent it from further execution. So if there's any downstream projects, they will not build. If you have any steps after that, they will not build. In fact, the build will fail altogether. We see that JaCoCo and its integration with Jenkins provide us with some great ways to enforce unit testing or testing in general within our applications. And that's going to build quality into our continuous integration practices. In this lesson, we will modify our Maven build to include FindBugs. For those of you not familiar with FindBugs, it is a static analysis tool that we can use to inspect Java code for common errors that may occur. For example, if you were piecing together a SQL query and executing it without using a prepared statement, that is something that FindBugs can flag as a quality deficiency. It's also able to detect other sorts of bugs such as obvious null pointer exceptions. FindBugs is incorporated into our build process much like unit testing and code coverage. We initially put the plugin into our Maven build, and the static code analysis is performed as part of that build, and during that analysis, a report is generated, and then Jenkins can leverage that report to provide us with more information about our builds within the Jenkins console. For us to get started, we need to navigate into our workspace directory where we are holding all of the Git repositories for our project. We're then going to navigate into the Maven test dependency project and work with its pom.xml file. We'll open the file with Notepad. We're going to be adding a reporting section within this file, and it's structured very similarly to the build section. Just going to copy that, and then below the build section, I will add the reporting tag. This will indicate the different reports that should be run during the Maven site lifecycle, which generates documentation about our project. We're no longer going to be specifying the executions, so we can go ahead and remove that section. Let's start working from here. We can specify the group ID of the FindBugs Maven plugin, and it's going to be org.codehouse.mojo. Then we simply switch the artifact name to FindBugs-Maven-plugin, and we're going to be using a much simpler version, 3.0.4. And at this point, we have specified the coordinates to that plugin that we'll be using as part of our Maven build. Now we're going to provide some configurations. This is telling the plugin how we would like it to behave. These configurations are going to tell the plugin that we would like to output a report, and we're able to specify the format of that report so that it can be used by the Jenkins plugin for FindBugs, which displays the report. The first tag we'll put in place is the XML output tag, and we want to set that to true. Then we close the tag. The next tag is the FindBugs XML output tag. That will also be set to true. Finally, we also need the FindBugs XML with messages. Be careful to watch your casing here. Then we need to close that tag out. This provides the appropriate configuration so that the Maven FindBugs plugin can interact with the Jenkins FindBugs plugin. So just take a moment to review the configuration, check for any opened tags that aren't closed or any spelling errors. If you're satisfied with the configuration, save the file, and you can go ahead and close it. From there, we're going to navigate back to the workspace, and we're going to bash into the workspace. I'm not going to commit the file yet, but I am going to use Maven to execute the clean, install, and then the site lifecycle. We should see our reports get generated if everything is correctly configured in our pom.xml file. There we see the Maven build kick off. It's running our unit tests. We should soon see FindBugs start to kick in. There I saw the analysis was done by FindBugs. Here comes our report, and our build was successful. Let's close that window, and if we now navigate into our project and look at the target directory, you're going to see the findbugs.xml file. This file is going to provide information to Jenkins so that it can display the FindBugs report, which is going to indicate to us the findings of the static analysis performed by the tool. And if there are any quality defects or bugs that FindBugs has discovered, we're going to be alerted to those. In this lesson, we're going to install the FindBugs plugin for Jenkins. We'll then configure a project to leverage the plugin so that we can display the results of static code analysis against our application code and display any bugs that were discovered. To get started, we're going to navigate into the Manage Jenkins section and then access the Plugin Manager. Within the Available Plugins tab, you're going to get a list of all of the available plugins. We're simply going to filter until we find the FindBugs plugin and then click Install without restart. You'll see the plugin start to install. There we can see it was successful. And I just like to come back into the Plugin Manager to make sure the plugin displays under my list of installed plugins. There we see we installed version 4.7. If we navigate to the Maven test dependency project, we can go into its configuration and look at the build settings. You'll notice that the plugin provides us with the option to publish the FindBugs analysis results. If we click on that, it is going to display the results of the static analysis conducted by FindBugs. Because we have configured our Maven build with the recommended settings, it will automatically detect that report and display it. Let's go ahead and apply that change to our project. We're going to need to introduce a bug into our project. I'm going to head into our workspace, which contains our GitHub repository. I'll navigate into our Java source code. From here, I'm going to open our message source class, and we're going to create another method, which will just say this is a bug, and we're going to place our bug into this method. Very simply, we're going to declare a string, assign it a value of null, and then we're going to invoke the uppercase function on that string. Obviously, we know the string is null. This is going to create a null pointer exception, and that should be a bug that FindBugs can pick up for us. Let's close the file now that it contains a bug. We'll navigate back to the workspace, and we're going to bash in. Let's take a look at the changes that are on our Git repository, and we can go ahead, add those in, and then commit the changes. This is also going to commit the changes that we made to include FindBugs within the pom.xml file. Let's just say including FindBugs in our commit. And at this point, we should have just triggered a build within Jenkins. So let's navigate back to Jenkins. We'll wait for that build to come in once the polling on our source control takes effect. There we see build 97 get queued, should move into the executor status soon. If we navigate into build 97, you'll notice that we get a FindBugs warning. We had a warning detected. If we take a look, you can see that it actually flagged those changes we put into our message source class. It was able to discover that bug. You get some information about the bug that was discovered. And if we take a closer look at the build, you see that we get just the overall summary warning. We can also navigate into the warning by looking at the FindBug warnings on the left sidebar, and that's another way that we can enter the reporting that was conducted via FindBugs static code analysis. If we navigate back to our project into the configuration, you'll see there are advanced settings for FindBugs. They're very similar to what we saw with the code coverage settings. You're able to set different thresholds. So you may allow a certain number of warnings that are high, normal, or low. Maybe you don't want to allow any high warnings, but you would tolerate 30 or so normal warnings. You would have to set these thresholds for the level of quality that you would like to enforce for your application. But you can establish those sorts of thresholds here within the plugin configuration, and they would all be determined by your personal preferences. So this is another way that you can control the quality of your continuous integration practices within your automated deployment pipeline. In this lesson, we'll incorporate the Checkstyle plugin into our Maven build. The Checkstyle plugin performs analysis of the layout and formatting of our Java source code. Checkstyle ensures that our source code adheres to a set of style roles that we can define. This helps ensure that all developer code reads in a uniform fashion and that it is structured in a similar manner. Just like our unit tests, code coverage analysis, and FindBugs analysis, the capability is built into the Maven build. The build produces a report that we can then display within Jenkins. So to start out, we need to modify our Maven build. We navigate to the GitHub repository for our Maven test dependency. Within this repository, we want to modify our pom.xml file to include the new plugin. We're going to be adding another report to our build. To do that, we enter the reporting section, and we're just going to copy the plugin because we're going to add another plugin for Checkstyle. So here we can see that we need to provide the Maven coordinates to the plugin, and the group ID for the Checkstyle plugin is org.apache.maven.plugins. Then we can change the artifact ID to maven-checkstyle-plugin, and we're going to be using version 2.17. Here's where things change a little bit. Instead of this configuration, we're going to be specifying some report sets. So we open a report sets tag, we close that tag, then within the body of that tag, we include an individual report set. Within the body of that tag, we have a reports tag. Within the body of that tag, a lot of nesting going on here, we have an individual report that we specify. In our case, that's going to be the Checkstyle report. That's the configuration of the Checkstyle plugin. Take a moment, check your end tags, make sure you've spelled everything correctly. If you're happy with the configuration, go ahead and save. Don't worry, we can always return back to this file for editing if necessary. Within the workspace, we're going to bash into the Maven test dependency directory. We're going to then use Maven to do a clean, an install, and a site lifecycle. Really, the important piece here is site. We kick that off. Here we see the Maven build start. It's running our tests. We should see FindBugs kick in soon. There's the FindBugs analysis. It's starting to download some of the jars required for Checkstyle, which is a good thing. There we see the Checkstyle report. We had a successful build, and we should see some evidence within our target directory that the Checkstyle plugin ran. There we see the checkstyle-result.xml file. We see checkstyle-checker.xml. So this indicates to me that the Checkstyle plugin was successful. Within our Maven build, we can now take these files and integrate them into our Jenkins continuous integration server. In this lesson, we're going to install the Checkstyle plugin for Jenkins. This plugin will allow us to display the reports that were generated by Checkstyle during our Maven build. In order to get started, we'll navigate to the Manage Jenkins section and then into the Plugin Manager. On the Available tab, we can see a list of all available plugins. We're going to filter for Checkstyle. There we see the Checkstyle plugin. Simply click the checkbox next to the name, then hit Install without restart. Here we'll see the status of the plugin installation. We can see it's in progress. It is successful. Let's just head back into the plugin manager, double check that it was installed. We should see it now under our installed plugins. And at this point, we can head to the dashboard into our Maven test dependency project. From here, you should see some additional configuration. The build settings section of our project's configuration will now include the publish Checkstyle Analysis results. We can go ahead and check that option. You'll see that there are advanced settings, and they're very similar to what we saw within the FindBugs advanced configuration. You're able to specify some thresholds that would cause a build to fail. You're also able to check the Run Always configuration, which will allow the Checkstyle plugin to run in the event that our build has failed. Let's go ahead and apply the basic configuration where we want to publish the Checkstyle analysis results. And that's going to cause the Checkstyle reports to be displayed for our project, similar to how the FindBugs warnings are included. And here we see some trends displayed for FindBugs. We'll see that sort of support kick in for the Checkstyle plugin as well. But the first thing we'll need to do is actually check in our pom.xml file changes, and that's going to initiate a build. Here we're heading to our Git repository for the Maven test dependency project, and you'll remember that we made changes to the pom.xml file. We're going to go ahead and add those changes to the stage, so just git add and then a period. Then we're going to commit those changes. So git commit -m and your message. So we'll just say we're adding Checkstyle. Now that we have committed those changes, we're going to see within Jenkins that a new build will get triggered. We should see it hit the queue and then the executor. One of the things you'll notice is that within that target directory, we are getting a lot of those artifacts produced. I wouldn't recommend checking those into Git as I have, but I don't want to dive into using the git ignore file just for the interest of time. There we see our build queued up, and it should move to the executor in a minute. Build 98's now with the executor. We can dive into the build to monitor its progress. If we take a look at our build, you'll see that the Checkstyle plugin is reporting 9 warnings. We can dive into those warnings via this display, or we can also use the left-hand sidebar. Here it gives us the different types of warnings, the categories they fall into. Here's the types, the warnings themselves, and where they reside. Here you can dive into the actual source code and the line that's causing the problem. Navigating back to the Checkstyle warnings with the breadcrumbs, we can see more information such as details for each warning. We can also take a look at all of the new warnings that were created. So we get a lot of information about the style and formatting of our source code. This information is displayed within the build, and you can see we're getting quite a list of quality checks that are being conducted on our code. And that's exactly what we want. All these automated quality checks on the product or project that we are building. And that's all provided with the integration of the tool into Maven, and then the integration of the reporting capabilities for Jenkins. And it's how we work to establish a build process that adheres to continuous integration, continuous delivery, and continuous deployment practices. We automate quality into the process. Another feature of this plugin that we'll discover is that we can display trending metrics. So here we see we're getting FindBugs trends, we get code coverage trends. If we were to kick off another build or two, you'll see that we should get some trend information on the Checkstyle results. It may take one or two builds. Let's see what happens here with 99. Build 99 finished. Let's see if we now get some trends for Checkstyle. And we do. We see that from build 98 to 99, we still had 9 warnings. These trends are a great way to see the quality of your project over time. They're a little bit sporadic and erratic with the way we're running these demonstrations, but over time you would want to see these trends improving for the quality of your application. Now that we have established several tools to check the quality of our source code, let's take a look at how we can use the analysis from these tools to impact the execution of our builds. So I'm going to navigate into the Maven test dependency project. Let's talk about a few things. First, we see the test result trend. We also see check style, find bugs, and code coverage. We know that within Maven, a failed test will fail a build, and that will keep Jenkins from further executing any build steps that we have configured for a project. But tools such as Checkstyle and FindBugs do not cause a build to be stopped, and the same goes with code coverage with JaCoCo. We can configure those sorts of thresholds to impact our builds and whether or not they will succeed or fail. So let's first start by looking at check style. I believe that we had 9 quality issues there. So if we were to set our status thresholds that if there are 5 priority defects, we can fail the builds. Let's save that change and we're going to build now. So you definitely see that Checkstyle has 9 at the moment. If we build, we should have a failed build. I just scheduled build number 100. We should see that build fail here in a minute. The build failed. If we take a look, we can see that the Checkstyle plugin has said that the 9 warnings exceed the threshold of 5, and that caused our build to fail. We're no longer going to proceed with any downstream builds at this point. Let's head back into the project. We're going to set up the configuration now of the settings for the FindBugs plugins. We had one FindBugs issue. We can go in once again to the status thresholds, and let's say that we want 0 defects within our code. And I'm actually going to go back into Checkstyle, raise that threshold up to something that will pass. Let's apply that change, and we can go back to our Maven test dependency project, execute one more build. We have build 101 in progress. We see that build 101 has failed, and if we take a look, we see that it failed because the one warning exceeds the threshold of 0 that we've established. I'm not going to walk through each one of our quality assurance checks and show you how it can enforce some of the quality standards because I think you can get the point from those too. But this is a great demonstration at how we can use these quality assurance tools beyond just reporting, and we can actually make automated decisions about our build process and its status and whether or not it should proceed. In this case, the build did not have cascading effects on downstream projects. Also, as you'll see, we can set up other steps such as deployment to particular environments that would also be executed or not executed based upon the thresholds we establish for these quality assurance checks. So, this is a way that we can enforce the quality standards established for our project using these tools. This is the end of our course, which focused on automating quality assurance with Jenkins. Let's take a few minutes to cover some of the key concepts once again. One of the key takeaways you should have received from this course is that by automating quality assurance checks, we can be confident that the software we produce has been scrutinized by a number of checks and validations. This helps us be confident that our software is of a higher quality. To achieve this, we used several tools that were incorporated into our build tool Maven. We saw how jUnit, Checkstyle, JaCoCo, and the FindBugs tools were interwoven into our build process, and they were able to help assure that our software passed several quality assurance checks. We also saw how these tools and the reports that they produced can be interwoven within Jenkins and how they integrated with Jenkins. We were able to display test results inside of our continuous integration server, then use those results to determine whether or not our builds should proceed or whether they should fail. This course pulled together several key concepts that are at the heart of performing continuous integration and building quality software. From here, you can move on to take a look at how the artifacts produced by our Jenkins project builds can be then deployed automatically to a particular environment. This is the next leg in the continuous integration, continuous delivery, and continuous deployment practices that we'll need to establish.